So find in the simplest form the integral of this expression here. So to integrate this expression right here, all we need to do is firstly make sure everything's in power form. Well, the first one is, so that checks out. The second one isn't because it's below the line and it's got a square root as well. So quick recap. If you got a square root of x, that's the same as x to the power of a half. So the opposite of squaring. And to bring it back on top line, so 1 over square root of x, that becomes x to the negative half. So this is the reciprocal. So negative represents the 1 over reciprocal business. So now rewriting the whole integral, we're going to have 8x cubed over 3, put a bracket there, minus, now because this is on the top line, it becomes x to the negative half over 2 minus 5. And that's it. Now integrating this one carefully, once again, you just raise the power by 1, so it becomes 8x to the power of 4 over 4, and because you've got 3 there, it becomes 3 times 4, which is 12. And now for the next part, again, you just add 1 to the power, so it becomes x to the power of plus half over, and then 2 times a half is just 1. And lastly, minus 5 just becomes minus 5x, and then plus c. So for constants, just stick an x in, yeah? That's all you need to do. Now, yeah, so now we're actually done. So all we want to do is just simplify your answer. So we could say, all right, 8 over 12, just smash down the calculator, you should get 2 over 3. Over 1, well, it's itself. So the final answer is just 2/3 x to the 4 minus x to the half minus 5x plus c. And that's it. All right, number 2. So given that y equals 3 to the x, express each of the following in terms of y. Write each expression in the simplest form. Now, looking at the first one, part A, yeah? It says 3 to the power of 3x. Before we just had 3 to the x. So the only thing that changed is that it now got an extra power of 3. So essentially it got cubed. So this means that y is now cubed. Okay? So for part B, we have 1 over 3 to the x minus 2. Now, what I would do for these kind of ones is I would always try and separate this in terms of different powers, yeah? So look at 3 to the x minus 2. We can separate this by saying it's the same as 3 to the x times 3 to the minus 2. This is because when you multiply things with the same base, you add the powers. So it becomes 3x plus minus 2 is x minus 2. Now, since we got everything we need, we know 3 to the x is a y, so it's 1 over y. 3 to the minus 2, if you put it in the calculator, you just get 1 over 9. And if you put this in the calculator further, if you write 1 over, and on the bottom half 1 over 9, you actually get 9 over y. Okay? So guys, when I'm answering the questions, we're just doing it in terms of how the calculator operates as well, yeah? That way we can solve this easily, and you can focus more on the complicated questions. Now for part C, we've got 81 over 9 to the power 2 minus 3x. Once again, we're going to use the indices laws and set this by powers, yeah? So I'm just going to look at the bottom for a second, yeah? So you've got 9 to the power 2 minus 3x. This is the same as 9 to the power 2 times 9 to the power minus 3x. Again, you always separate by plus or minuses, yeah? Now, what do we know so far? Well, we know that 9 squared is just 81. Now 9 to the minus 3x, well, you got a negative power, so that's just 1 over 9 to 3x. Now the weird thing about this one is that it's no longer in terms of 3, but if we look carefully, we know 9 is actually 3 squared. So this is also the same as, let's scroll it down a bit, 81 times 1 over, so 9 is just 3 squared, put a bracket and then copy the rest, 3x. Now, this is where we can actually get it done. So just looking at this carefully, this is now the same as 3 to the power 6x. And we know what 3 to the power 3x is y cubed, meaning this is just y to the power 6, because you got, instead of 3, you got 6 now. So all of this is actually just, well, doing it further again. So just updating your solution. We got 81 over 9 squared, which is 81 times all of this fraction, which is 1 over y to the 6. Ooh, it looks like we're almost done. And now looking at your some quick calculation, you got 81 up and down, so they cancel out. So you have 1 over y to the power 6, which is just y to the power of 6. Okay, so when you're dividing by a fraction, the bottom half goes on the top. That's how it works. And 1 goes on the bottom. Yeah. Yeah, and that's it, I guess. All right, number 3. So figure 1 shows part of a curve with equation y equals x squared plus 3x minus 2. So this is a quadratic U-shaped equation, yeah? Point P at x equals 3 and y equals 16 lies on that curve. So here's your P. A. So find the gradient of the tangent of the curve at that point P. Okay, so to find the gradient of any equation, always find dy over dx, because that's the gradient expression. Now, since we know what the equation of the curve is, it's given over here, we just have to differentiate that. So for A, we just say, okay, dy over dx. If you differentiate this one, the rule is that you just drop the power and subtract it by 1, so it'd be 2x. Subtract 2 by 1, just get 1, so it's just 2x. And if you just go on x, well, that vanishes, so it becomes plus 3. For constants, they always become 0 because there's no x attached to them. Now, since we got the gradient expression, it says find the gradient to the curve at point P. Well, at point P, you can see that x equals 3. So we say, all right, at P, x equals 3, so dy over dx, which we can call it gradient at point P, is just 2 times 3 plus 3. 2 times 3 is 6, plus 3 gives us 9. And that's it. That's A done. Alright, so moving on to part B. It tells us that the point Q with x coordinate 3 plus h also lies on the curve. Okay, so now we know what the x is. We can easily find the y using the curve equation. And then B, find in terms of h the gradient of that line. Write your answer in the simplest form. Okay, so first things first. Let's find what the y coordinate of Q is, yeah? So we can say at Q, since x equals 3 plus h, what I'll do, I'll substitute that directly into our quadratic equation, yeah? So this means y equals 3 plus h squared plus 3 times 3 plus h minus 2. Ooh. Okay, so one quick note, yeah? When you got a square bracket, this just means there's 2 of them, yeah? So this is just, let's expand it. It's just going to be 3 plus h times 3 plus h. And then copy the rest. You got 3 times that, which is 9 plus 3h, and then minus 2. So to expand this double bracket, I always draw arrows, yeah? So you got 3 times 3, and then 3 times h, and then h times 3, and h times h. Whoa, yeah, there's a lot of h's there, isn't it? So now expanding that carefully, so let me put the equal bit lower. We're going to get 9 plus, so 3 times h is 3h, plus another 3h is 6h, plus h squared, and then copy the rest, plus 9, plus 3h minus 2. Okay, so, and then just tidying this up a bit. So what we have is, I always do in quadratic order, yes? Yeah? So I always do the highest power. So it's going to be h squared plus, and then 6h plus 3h is 9h. And we've got 9, add 9 is 18, take away 2 is plus 16. Okay, so we have a coordinate of Q now. So therefore, coordinate of Q is at x is 3 plus h, at y is all of that, h squared plus 9h plus 16. Okay, so far so good. What do we do with this? Well, now we want to find the gradient of the line PQ. And just a quick recap, yeah? P, like earlier, was known to be 316, yeah? 316. And to find a gradient between 2 points, you just find the change in their coordinate points. So change in y over change in x. So we say that the gradient of the line, what's it called, PQ, is just simply the change of them, yeah? So change in y coordinates over change in x. Well, the change in y, so it'll be h squared plus 9h plus 16 minus 16 is just h squared plus 9h. 16's cancel out, yeah? Over the change in x, 3 plus h minus 3 is just h. And then you can kind of see that you can simplify this further by cancelling h on both. You're left with h plus 9. And that's it, guys. That's B done. And then now quickly looking at C here, explain briefly the relationship between your answer in B, so your gradient of h plus 9, and your answer to A, your gradient of 9. Well, there is one relation we can see both. First things first, they both have a 9. And the only way they can be related is that, and this is what we say, if h approaches 0, so as the limit for h goes to 0, then the gradient will result to 9. That's what it is. Or MPQ, the line will result in 9. It's just kind of like some sort of limit differentiation theory, yeah? I won't go too much into detail of that here because we just want to solve questions. But if you want to know further, just drop me a comment and I'll get back to you guys. Anyways, see you next question. Alright guys, here we go. Number 4. So figure 2 shows the plan view of a house ABCD and a lawn ABCDA. So just look at the shape carefully. Looks like we had a circle originally, but it got cut in a really awkward way. So it looks like we got a radius from O to A and a radius from O to C and a rectangle trimmed out. Okay, so here's our radius for both sides. Now it says that ABCD is a rectangle with a length of 16 across as AB. So here's 16, meaning its parallel length is also 16. Now this part, APCOA, so APCOA, okay, here's the sector. So we've got a sector going all the way around like this, and with the radiuses, has a radius of 12. Okay, sorry, I was just thinking about it. So the radius is 12. This means AO has a length of 12, and OC also has a length of 12. Okay, so that part's good. We know this is 12. This means that this short length here automatically, just by looking at the fact that that's 16 and this is 12, this must be 4. So try and get as much info as we can, guys, yeah? The point O lies on the line DC. So ODC, check, as shown in figure 2. Now part A. Show that the size of angle AOD, so AOD, so we're talking about, I'm going to use a different color pen, this angle here, yeah, is 1.231 radians. Okay, so first things first, set your calculator, guys, to radian mode. Now to show that this has an angle of, that radians, what I would do is just look at this and ask myself, what kind of triangle is that? Well, first things first, we have a right angle triangle, yeah, and it looks like that, with a right angle here, an unknown angle here, let's call it X, a length of 4 and a hypotenuse of 12. Now, using trigonometry or SOHCAHTOA, so all we need to do is just label the right side with the appropriate term, yeah? So I'm just going to look at this, yeah? The 4 here must represent the adjacent because the opposite is opposite angle, which is this long length here, and this diagonal length is the hypotenuse. So essentially we have an A and a H, and we ask ourselves, which one has A and H? Well, K has it. And to write K, C is for cos. This is going to be represented as cos of the angle X must equal A, which is the adjacent, which is 4, over the hypotenuse, 12. And guys, we're almost there now. And then when you cos inverse this result, so X equals the cos inverse of 4 over 12, which is also a third, by the way, you're going to get the radian result of 1.231, 23 dp. That's it. That's all you need to show. So make sure you guys draw a right angle triangle. Try and write SOHCAHTOA. It actually helps. Always label diagram as much as you can, and then straight up answer A. Now for B, and before B, it says that the lawn above is shown shaded in figure 2, so the bluish region. Find the area of the lawn in meters squared to 1 dp. Alright, so this is the main question now. Now, my tip here is to think about how you would shade this in, yeah? The good thing is that they told us earlier that that shape is actually part of a sector, right? And the only difference is now is that this sector got its triangle cut off. So what I would personally do, find the area of the sector, find the area of this triangle, and then subtract it. So what do we have? Well, the area of the sector is called AS. It's just always a standard formula. It's half radius squared times your angle theta. That's just a general formula. In this case, our radius is 12, so half times 12 squared. And that angle of interest, well, this is can be a bit weird. We found this angle X here, but we're interested in the whole thing around it. Now, if you look at carefully, because we're working in radian mode, if it was degree, this would be a straight line, 180 degrees. In radians, this is known as pi radians. So we've got pi plus that small angle, 1.23. So our angle actually is pi plus 1.231. And then put this in a calculator, you're going to get some result. But before we do that, we want to find the area of a triangle now. And now to get the area of a triangle, we just look at this triangle here and ask ourselves, okay, we need an angle between two lengths. Well, we got the angle X, we got two lengths. The general formula is always half AB sine C, where AB are the lengths between the angle C. So we've got half times A and B, so 4 times 12. It doesn't matter what order you guys put at, yeah? times sine of the angle between them, which is, what is it, 1.231. And that's it. And then when you do this, when you work out both of them, you subtract the results and you should get a difference of, so the area of the lawn equals 292.2 meters squared. Okay, so that's so far B done and A done. Now one more to go. Okay, so for part C, they want us to find the perimeter of the lawn. Okay, so the perimeter of the lawn is just this length around here, yeah? All of these lot. Now, to work out the curve length, and this is the most important part, I think, this is what's it called? This is basically a fraction of the sector, yeah? So the circumference of the sector. Now, the formula for the circumference part of the sector, let's call it PS or something, perimeter of the sector bit, is just r times theta. So the radius times the actual angle length, yeah? And well, because we're interested in an angle this big, we're talking about the whole thing round again. And if you remember carefully, it was pi plus that 1.231. So therefore, the radius, which is 12, times the angle, which is pi plus 1.231. Okay, that part's cool. The other part we might be interested in is actually this part here, this length up here, because we need to add this length, because we already got 12, we got 4, we just see that last bit here. Let's call this one x, yeah? So actually, this right angle triangle, we have it here already. We can call this one x. And to get that x, that's just Pythagoras' theorem. So using Pythagoras' theorem, it's just x squared plus 4 squared is 12 squared. So let me write it here. And to get x, 12 squared. To get x squared, just rearrange it. So you're going to get x equals, well, 12 squared minus 4 squared, all of that square rooted. And you get an answer of, well, inside is 128 and a square root of that. For now, I'm just going to leave it like that, yeah? Just because we don't actually need to work it out until the final step, yeah? So therefore, we can say that the total perimeter of the lawn is, well, the result of PS, the perimeter sector part, plus that x result, which is root 12a, plus, well, we also got this length across, 4 plus 12, which is 16. And then just, you know, just smashing on the calculator, you should get a result to 1 dp of 79.8 meters. And that's it, guys. That's 4 done. All right, number 5. So find, using algebra, all solutions of this cubic equation. Okay, so what it's trying to tell us here is that we should always see if we can firstly factorize this, yeah? Because that's what the solutions mean. Now, because it's a cubic term, this means that it's got 3 solutions because it's power of 3. Now, first things first, looking at all the terms, it looks like you can pull out an x. So let's go ahead and factorize here, yeah? So for part A, I'm going to factorize x out. So it'll be x bracket, you're left with 20x squared minus 50x and just minus 30. Now, what I could have also done, actually, I could have actually divided all of this by 10 because they're all in the 10 times table. So I'm going to do that right now. I'm going to just divide everything by 10. So it'll be x bracket 2x squared minus 5x minus 3 equals 0. Now, I could factorize once more, actually, or I could use the quadratic formula. Now, just to make it easy for, like, just because we're watching on YouTube, I'm going to go ahead and use a quadratic formula on this equation, yeah? And just a quick recap, guys, yeah? The quadratic formula always takes this form, where we've got ax squared plus bx plus c, and it must equal 0. Now, because we have values of a, which is 2, b, which is minus 5, and c, which is minus 3, we could use the formula quite easily. So the formula is like this. It's x equals minus b plus minus the square root of b squared minus 4ac. And all of that over 2a. So from here, guys, carefully replace the values, yeah? So in your calculator, you got minus b, so it'll be minus 5, so plus 5, plus minus the square root of, well, b squared is minus 5 squared, which is plus 25, minus 4 times a, which is 2, times c. Okay, for these terms AC, always wrap them nicely in the brackets, yeah? So that way you don't avoid mistakes. And now all of this over 2 times a, so 2 times 2. Now, when you put this carefully in the calculator, first copy this and replace the plus minus with a plus sign, and then again with a minus sign. When you do both times, you get 2 solutions. What was it? Minus a half and x equals 3. Now we also had another solution. Remember I told you it's cubic, we have 3 solutions. Well, the other solution is up here. We also know that this equation becomes 0 when x is 0. So 0 times anything is 0. So the other solution, the easy one, is x equals 0 from here. And that's it, guys. This is your 3 solutions. Now if we look at B here, it says hence find all the real solutions of this equation here. Yeah? Now looking at this carefully, I'm not gonna lie, it looks a bit tricky at first because you've got powers of a half and a 3 over 2, and this is nothing, or power 1 actually. It's actually the same equation. The only difference is, and if you look at the 30x bit here, the x is literally now y plus 3 to the power half. And looking at x cubed is y plus 3 to the power 3 over 2. So you can imagine this was power 1, this is now 3. So this power is cube size bigger than that. So what we can say from here is that x must be clearly y plus 3 all to the power of half. And now it wants us to find the solutions of this. When they say real, it means solutions that actually make sense in your calculator, that give you an answer. There's also something called imaginary solutions, but we're not going to deal with that here. So from here, we can use each of our x values to get corresponding y values. Well, if I plug in firstly, let's say x equals 0, yeah? So let's just pull this a bit down actually. So we can say using, and this is part B, x equals y plus 3 to the power of a half. Therefore, when x equals 0, well, just making the subject. Actually, you know what, before we even get there, how about we go ahead and make y the subject, yeah? And then you can just plug everything in. So if I make y the subject, I would firstly square both sides. So we're going to have x squared equals y plus 3. Therefore, y equals x squared minus 3. Yeah, this is easy now. So let's put, is that copy right? Yeah. So let's put everything in, yeah? So when x equals 0, this means y equals, when x equals minus half, you're going to get y equals minus 11 over 4. And lastly, when x equals 3, plug into the formula, you can get 3 squared, which is 9, take away 3, which is 6. And that's it. All right, number 6. So the first line has equation given by this, and the second line cuts the x-axis at a certain point and is parallel to the first line. All right, so these are some key info here. Find the equation of line L2. All right, so for this kind of question, so because we're dealing with lines, it's always important to write every single equation in the standard y equals mx plus c form. Now, I highly recommend this only because in this way we can easily find m, which is a gradient, and c, which is the y-intercept. Now, a keyword is used here. They tell us that line 2 is parallel to line L1, so that's one thing, meaning L1, L2 have the same gradient. So parallel lines always have the same gradient. And also the fact that at L2 it cuts the x-axis at this point. So we can use it to find plus c after, yeah? Now sticking with this, so looking at part A, we can say that first things first, let's rewrite L1 into the standard y equals mx plus c form and obtain the gradient, yeah? So for the first one, I would probably plus 4y across. So we're going to have 4y equals 3x plus 20. Then I'll just divide 4 across. So y equals, well, 3/4 x. And then 20 divided by 4 is 5. So this is all for L1, yes. So let's call this line L1. Now we know that L2 is parallel to this line. So this means that for L2, we know it's going to have the same gradient, so 3 over 4x, but it's going to have a different intercept, c. Now when we work out c, well, we can easily rewrite L2 into the form they want. And we're done. So what's the other crucial info here we had there? Well, we know the fact that line L2 cuts the x-axis at this point. So let's go ahead and replace this equation with that coordinate, yeah, because it's on that line. So we can say, all right, at R, which is at 8, 0. This means when x is 8 and y is 0, we're going to have 0 equals 3/4 times 8 plus c. Now all you want to do is just literally rearrange this. So 3/4 of 8 is just 6. Move it to the other side. Therefore c equals minus 6. And therefore our line L2 can be updated to y equals 3/4 of x. Instead of c now we got minus 6. And that's it. That's your question done. Now they want it in a certain form, by the way, guys, which is ax plus by plus c. In other words, where each of these are integers. So we just have to clear the fraction and throw everything to the left. So what I'll do here is just multiply the whole equation by 4 to clear the fraction. So it'll be 4y equals 3x minus, and then 4 times 6 is 24. And now, again, just move it into their form, so make it equal to 0. So I'm going to move everything to the left-hand side, yeah? No, actually, I'll move 4y across, because there's only one thing. So we're going to have, therefore, 3x minus 4y minus 24 equals 0. And that's the first part done. Now, so next part. So the line L1 cuts the x-axis at P and the y-axis at Q. So far it's all about cutting certain axes, yeah? So when a line cuts the x-axis, it means the y-coordinate is 0. And when a line cuts the y-axis, it means the x-coordinate is 0. So automatically, we know P has some coordinate at x with a y-coordinate of 0. And Q has a coordinate of x-coordinate of 0 and a y-coordinate which is unknown. Now, actually this is easy to obtain, because since we know line 1 is the one that cuts it, you can just use the line 1 equation, the L1 equation. So we can say, okay, when, let's see, so at P, so that's it, when y equals 0, what does that mean? We're going to have 3x minus, 4 times 0 is 0, plus 20 equals 0, meaning x here must equal minus 20 over 3. So that's the x coordinate. Now, and we can also say at Q, x is 0. So this implies that, well, replace x with 0, we're going to have 3 times 0 is 0. So we're going to be left with minus 4y plus 20 equals 0. So, and then finding y, just, what is it, minus 20 and divide by minus 4, you're going to get a y value of 5. So therefore, our two coordinates so far for P and Q, so just updating these values here. So let's just update this one, yeah. So x coordinate will be minus 20 over 3, and y is 0, and here is 0, 5. Okay, so given that PQRS is a parallelogram, find the area of that shape and the coordinates of the point S. Alright, so I think we're going to need a fresh page, yeah? So let's get a new page up. Alright guys, so over here, I've decided to put all the necessary equations we have, so L1 and L2. I've also put all the coordinates that we know so far. So we got P, we got Q, and we got R. And I thought, you know what, let me just rewrite this improper fraction as a recurring decimal, yeah? Why not? Now, to find the area of this shape PQRS, I think it's important that we firstly try and draw this parallelogram, yeah? Because it always helps to visually see things. It might actually help us solve it. Now, thankfully, it's good to always draw an XY axis, yeah? Because you know the actual coordinates, we might as well just plot them in, since we need to find S anyway. So first things first, I'll plot Q, yeah? So every single block I'm going to count in 2s. So it'll be 2, 4, 5, that would be our Q. P will be minus 20 thirds, which is minus 6.66. So it'll be 2, 4, 6 on the left. And I'll say it's about here, yeah? And lastly, 8, 0. So that's 8 on the right. So 2, 4, 6, 8. And just label your points. You got, this is Q, P, and R. And because we know it's a parallelogram, well, we know that, let's connect these two first. We know it's going to be parallel anyway. So if you guys got a ruler, if not, then just use like the side of your exam worksheet or something. So we know it's going to be parallel, and it looks like it's more weighted to the right because there's more values on the right. So let's just try and see if we can make some sort of parallelogram. I think it'll be somewhere here, and it will shoot up like that. So it's going to be somewhere on this quadrant. This will be our S most likely. Now, and then we just label parallel sides. So these two are parallel, and these one is parallel as well. So they're not all parallel with each other. Only the opposite sides are parallel in a parallelogram. Okay, so to find that area of this parallelogram, my personal trick is to just find the distance between P to R. Well, we know what that is because it hits at P at, what is it, minus 20 over 3. And it hits at R at, 8. So just find the actual distance there. So if you sum up those two, it will be 8 plus, and then this is kind of a width of 20 over 3. And then you times against the vertical height that's basically from the origin to Q. And we know at Q is at 5. So we times this by 5. And because it's a triangle, well, if you think of all of this as one massive triangle, you're going to now divide the result by 2. Okay? And interestingly, because a parallelogram, the area of the top half is also equal to the area of the bottom half. So technically, you can just times the whole answer by 2 again, which essentially just cancels these out. And when you do all of this calculation, well, you're going to get an actual area of 220 over 3 units squared. That's it. That's B done. Now, as for the coordinates of S, there's a really nice way to calculate this, yeah? So let's look at a parallelogram one more time. So let's start P, for instance, yeah? Because we know like this side is parallel to this side, we can also assume that the distance we travel from P straight across and then all the way above Q is going to be the same distance if we went from R all the way vertically down to S. That's, oh, it should be a straight line. So that's what we assume, yeah? So what this is actually telling us is that, well, what is the distance between P and over here? Well, that's of course a distance of 20 over 3. What's the distance from the origin to Q? Well, it's a distance of 5. So what this means, starting from R, we're going to go back by 20 over 3. If you do 8 take away 20 over 3, you're going to realize that this x coordinate is 4/3. Now, if you go from here downwards, well, this is the y-axis. If you go from 0 down by 5, well, you're going to be at -5. And there you have it, guys. This means that the s coordinate must be, well, 4/3 and -5. And that's it, guys. This is actually C done. All right, number 7. So figure 3 shows part of the curve C with equation y equals 3 sine x, where x is measured in degrees. Now the point P and Q lie on this curve as shown in figure 3. Okay guys, so before I even look at the red box and questions, we need to firstly recognize the sine x graph here. So suppose this was just a regular sine x graph here, so y equals sine x. We need to know a few things. First things first, for sine x graph, we need to know that the height of it, the range of it is from 1 all the way down to -1. Because you're dealing with 3 sine x now, so y equals 3 sine x, you just multiply all the heights by 3. So now this goes all the way up to 3, and this goes all the way down to -3. So 3 and -3. As for the rest of the points along the x-axis, well, nothing changed because the sine x is still sine x. Now what this tells us is that for the first loop at the tip of it, this is going up in 90, yeah? So always, every single peak or at crest always shifts to 90. So this would be 90, this would be plus 180. The next peak at the bottom would be 270 and so on, 360. So what I always do, it's always good to just do them, yeah? 360 plus, what is it? 90 is 450. And the next one would be 540. Okay. So that's so far so good. Now let's check out the questions. So 1, A, state the coordinates of P and the coordinates of Q. You get 3 marks for that, so that's chilling. So at point P, well, the x is 90 and y is 3, so it'll be 93. And for Q, well, Q is at right at the end, so it's 540 and 0. So that's actually done. A is done. Now next one. A different curve C2 has equation 3 sine x, so the same thing, but plus k, where k is a constant. Okay, when someone says plus another term, this means that the graph is shifting up or down by k. So we can assume that maybe it's going up by k or down by k. Right? Now, curve C2 has a maximum y value of 10. Ooh. So this means if the maximum y value is 10, so let's assume it's second, yeah? This is telling us that we got 10 equals 3 sine x plus k. If that's the case, that means the only way this could be a maximum if either, well, x is 90 or 450, if it hits at 3, right? Now, but it's telling us it can go up to 10, so meaning we can add an additional 7. So k must be 7. Okay, because 3 plus 7 will give us 10. Alright, so this is actually useful, so k must be 7. Now, the point R, guys, is the minimum point of C2 with the smallest positive x coordinate. Okay, so the minimum point of C2. I mean, if I looked at C1 for a second, well, the minimum point is -3 and it occurs at 270. So I know for sure the x coordinates will be 270 because it's the same graph, just shifted up by 7. I guess you could just add 7 upwards. It'll be 7 plus -3, which is 4. R will be 270 and plus 4. Yeah, not bad. That's really it. All right, number 8, guys, yeah? Ooh, so let's try this one out. Now, it tells us that the straight line has equation y equals k, oh, they got k in now, 2x minus 1, where k is a constant. The curve C has a quadratic equation, cool. Find the set of values of k for which L, so the line on top, does not cross or touch the curve. All right, so to me, like, if I'm just looking at this, there's a k, they don't want to touch. This sounds like a discriminant question. So this is telling us that we need to find the discriminant, which is b squared minus 4ac, that is less than 0. Because if you look at this problem visually, suppose we've got a quadratic curve, which is a U shape, and we've got a line, and we know that it's got a positive gradient. Well, that's assuming k is positive, yeah? Let's assume that it's like this. One possibility is that it could look something like that, or it could look something like this. Just guessing, yeah, because we don't know which way it's going. This is the kind of interpretation we're getting. So we cannot cross it, but it'll be something like that, where k could be a positive gradient, or k could be negative going downwards. Now, the only way we can solve this is use a discriminant, because this discriminant, when it's less than 0, tells us that they do not intersect. Okay, so there is no intersection between line and curve. Okay, and there's no roots as well. So let's have a look. Now, what I would personally do is firstly equate these two equations here, only because we need to show that they don't intersect. So we've got to find values that will not make intersect. So let's make these two equal, because they both equal y. We're going to have x squared plus 2x plus 11 equal to, and I'm going to expand the bracket, 2kx minus k. And now I would actually move this all to the left hand side, yeah? So we're going to have x squared plus 2x minus 2kx, and then we got plus 11 plus k. Oof. Almost made this mistake saying minus k. And now to rearrange into the actual quadratic form here, we need to actually somehow factorize the x in this part. So let's look at in the beginning. So we've got x squared, which checks out. Now for this part, we need to factorize the x. So we're going to get bracket 2 minus 2k with x factored out. And then the last bit is the constant. So we've got 11 plus k, which is the c bit. Now that's all checks out. So we can just highlight that. So this is a b, this is c, and we can just imagine there's like a 1 in front of the x squared, yeah? Now using the discriminant formula, we're going to have b squared, which is 2 minus 2k squared, and then minus 4 times a, which is 1, and then times that by c, which is 11 plus k less than 0. So now we just got to deal with this inequality and find what k could be between. So let's move forward. Now to expand this squared quadratic, just remember that when you got a squared quadratic, it literally means there's 2 of them. So 2 minus 2k times 2 minus 2k, okay? And to expand this carefully, you just do 2 times 2, and 2 times minus 2k, and then this times that, and this times the last term. So you should get something like 2 times 2, which is 4, 2 times minus 2 is minus 4k, and then you get another minus 4k, which is minus 8k. And then minus 2k times minus 2k is plus 4k squared. Expanding the second bit, you got minus 44 minus 4k. Whew. All right, almost there, guys. So at this stage now, we're just going to rearrange it in quadratic order. So we're going to have 4k squared. And then you got minus 8k minus 4k is minus 12k. 4 take away 44 is minus 40. And now, can we do anything else? Yep, we can. We can try and simplify this, divide 4 across. So I'm going to do it from here. So you got k squared, so therefore you got k squared minus 3k minus 10 is less than 0. Now, if you want to go ahead and solve this quadratic, you can use the quadratic formula. You can probably use your calculator most likely, or factorize. I'm going to go ahead and factorize it. But when you do factorize it, you should get roots, which is a root of minus 2 or plus 5. Now, because you're working with inequalities, we've got to wrap it around with inequalities. So there's a little tip here. If the quadratic is less than 0, this means it's going to be within, so between, yeah? In other words, k is going to be between minus 2 and plus 5. Now, if for some reason this was a greater sign, it would be the other way around. It would be outside this value. So it would be k less than minus 2 or k bigger than 5. But in this case, we're sticking with the less than sign, yeah? And therefore, our result is going to be between this range. So these lot are definitely wrong. And that's it, guys, we're done. Alright, so a curve has equation given by this mixture of a quadratic and reciprocal equation. Find the x-coordinate of the point on the curve at which dy over dx equals 0. Okay, so they kind of tell us what to do. They want us to firstly get to dy over dx, so that's the first thing we should do. Now to get this equation to dy dx, we need to rewrite this into index notation, yeah? So my advice is, because you're dividing the whole top by 2 over root x, we can partition a fraction. We can say, alright, let y equal, well, 4x squared over 2 root x plus, and then do 9 over that, 9 over 2 root x. And then we should just try and simplify this as we go. So doing over here now, we have y equals, well, 4 over 2 is just 2, x squared over root x. Well, if we recall from question 1, I think it was, root x is the same as x to the half, yeah? And well, when you're dividing x terms with the same base, you subtract the power. So it's going to be 2 take away a half, which is 3 over 2 or 1.5. So just to make it easy, I'm just going to write x to the power of 1.5. Now the next part, plus, well, 9 over 2 is 4.5. And then root x against x to the half. To bring it upwards, it would be x to the negative half, or 0.5, minus 0.5. So now we got this sorted out, we can go ahead and differentiate this into the dy over dx form. So therefore we say dy over dx, well, to differentiate, the rule is that you drop the power, so it'll be 2 times 1.5, which is 3. And you subtract the power by 1, which is 0.5 or half. Likewise, do the same thing here, so it'll be 4.5 times minus half. Well, what I always do is just put that in the calculator so you don't get a mistake, and you should get minus 9 over 4x, and then subtract the power by 1, you get minus 3 over 2. Again, it's up to you, decimal form, fraction form, it's all good. Now that you've sorted this out, they said find the x-coordinate of the point at which this equation is equal to 0. So then we can say, alright, therefore all of this should be equal to 0. Now just go ahead and rewrite and make x a subject. So let's go ahead and pull 9 over 4 x to the minus 3 over 2 to the other side. So we're going to get 3x to the power of a half equals 9 over 4 x to the negative 3 over 2. Okay, now a quick rule of indices, yeah? My personal advice is to just literally divide the entire term across. Put all the x's on one side, numbers on the other. So what I would do, I'm going to throw ahead, divide x to negative 3 over 2 across, and divide this 3 to the other side. So moving this to the left, we're going to get, and moving 3 to the right, we should now get x to the half over x to the negative 3 over 2 equals 9 over 4 all over 3. Now, this is easy. Now we're pretty much done here. In your calculator, just write, when you're dividing x terms, you subtract the powers, yeah? So it'd be half take away minus 3 over 2. Well, that should give you x to the 2. So half take away that gives you a 2. And 9 over 4 divided by 3 should give us 3 over 4. And what we're done here. We're actually almost done. Now they want us to find x coordinates, so well, square root the result, and you should get x equals plus minus root 3 over 2. And just checking which x coordinate they want. It said early in the beginning that x is greater than 0. It's positive. In other words, we want the positive solution. So therefore, the real solution is just x equals root 3 over 2. Yeah, and that's it, guys. That's this one done. All right, number 10. So curve C1 has equation y equals fx, yeah? Now, A, sketch this curve showing the coordinates of any point where the curve touches or crosses the coordinate axes. Alright, so as it says, we just draw our xy axis, and we just need to know where this cubic curve, so we know it's cubic because you got a linear term here and you got 2 linear terms here because it's squared. And when you got 3 of them, it makes a cubic. Or if you expand it, well, you'll get a cubic term. Now, to know what the points of intersection are, so when you sketch something like this, we always set this to 0. We ask ourselves, well, what are the solutions of x? Well, in the first case, you got 4x minus 3 is 0. This automatically means that x equals, well, 3 over 4. You just rearrange it. As for the second term, because it hits at x equals 5 twice, then on the curve, it's going to bounce off the x-axis. So if it hits once, it goes through. If it hits twice, it bounces. So we've got a repeat route here. Now to plot this, Well, since we know what the coordinates are, hits at 3 over 4, which we can say is there, and hits at 5, which we can just imagine is there. We also need to know where it hits on the y-axis now. Now, a quick way to do this is to just literally multiply these constant terms, yeah? So if I was to expand this slightly, showing 3 brackets, like 4x minus 3 times x minus 5, and then another x minus 5, and of course, y equals. If I just focus on the last 3 constants, yeah? If we do minus 3 times minus 5 times another minus 5, it's going to give you, well, minus 75 actually. So this means it's going to hit somewhere at minus 75. And now if we draw the cubic curve, and we should know the cubic curve always looks a bit like that, yeah? If it's positive, it starts at the bottom, shoots up. This means it's going to cut through here, hit at 3 over 4, and then instead of going through 5, because it hits that twice, you can imagine it as bouncing off it. And that's it. This is pretty much all you need to show. So you hit the x coordinates and you hit the y coordinate at minus 75. Okay, I think that's it then, yeah? As for part B, it says hence or otherwise, find the values of x for which this function at the point, so the same function at the point, instead of x is a quarter x, equals 0. Alright, all that's literally saying to you now. So since you know what the function of x is, well, we just replace all these x's with that value. We could just replace the x solutions here with a quarter x. So for instance, it says 3 quarters, right? Instead of x equals 3 quarters, we can say a quarter x. Well, I'm going to rewrite this as x over 4, guys, yeah? X over 4 now equals 3 quarters, and x over 4 now equals 5. Well, this is straightforward. Just times 4 across, then x here would equal 3, times 4 across, and now x equals 20. I think that's just the I part done. Now for II, it says find the value of the constant p such that the curve with equation y equals the function plus p. Okay, so what this means now, if it's plus p, it means that the curve now shifts upwards or downwards, depending if it's positive or negative, yeah? And passes through the origin. Okay, alright, so it tells us already. So in fact, this curve actually passes through the origin, so it's the same curve now. If this entire curve shifts upwards by p, this means this curve, instead of hitting at minus 75, it hits at 0 now, right? That means all of this, if it's instead of 3 quarters, it's gone up by, well, it's gone up by 75, isn't it? So that means it hits at 3 quarters 75 here. And this 5 also hits at, well, 75 too. And it shifts up. Now, find the value of the constant p. Well, clearly p in this case must be 75. Because the only way we can hit the origin if it went up to 70, went up by 75 points across the y-axis. Alright, so that's all good so far. Anyway guys, so far if you guys got any doubts or questions, you know, always drop a comment and let me know. So, but let's have a look at the second bit. A second curve C2 has equation y equals gx. Alright, so just recap here. The previous one was called fx, yeah? Where gx equals fx, or f at the point x plus 1. So instead of fx, you're going to replace x with x plus 1, yeah? And those two are equal now. And for part C, it wants us to find in its simplest form gx. Alright, let's make this clear. So all they want us to do is just literally equate gx with fx plus 1. Or in this case, gx is fx plus 1. So let's go ahead and replace all these x's with x plus 1, guys, yeah? So this means that therefore gx is going to equal, well, at x plus 1, we're going to have 4 times x plus 1. So what I would do, instead of writing x plus 1, put in a little bracket, yeah? Like that. Copy the rest of the equation. Times, instead of x again, it'll be x plus 1 minus 5 all squared. And just to make life a bit easier, I'm going to make it twice, yeah? Just put 2 brackets. X plus 1 minus 5. Alright, so I can see what they're kind of doing here now, yeah? It's going to be kind of long. Okay, it says find in simplest form, and you may leave your answer in a factorized form. Okay, sweet. So we actually don't have to expand it. So we just have to tidy up the inside. Right, so what that means then, yeah, so looking at this one, and instead you can keep it as a squared bracket then. Let's keep it as a squared bracket, guys. Alright, so on the first one, I'm going to expand this nicely, yeah, so it'll be 4x plus 4 minus 3. And doing it quickly, well, 4 take away 3 is just a 1. So that part is done. Second bit, x plus 1 take away 5, well, that's just x plus 1, because there's nothing before it, take away 5. And put a power 2. And well, 1 take away 5 is minus 4. Yeah, minus 4. So just put minus 4 there, squared. And yeah, that's it actually. And part 2, hence or otherwise find the y-intercept of this curve. Alright, that's not bad. That's literally like we did for part A, yeah, where we found minus 75, but we just multiplied the 3 last terms, yeah. So again, we do the same thing, and just to make it clear, I'll put this as 2 separate brackets, and then to get the last intercept, it's going to be plus 1 times minus 4 times minus 4, which means, so for part 2, we say that the y-intercept of C2 is just 16. That's it, guys. And here we go, guys, the final question. So what do we have here? So now it says that a curve has equation y equals fx where f to the second derivative, so this is the second derivative, equals this function here. Alright, so instead of the usual way, they're starting off with literally d2y over dx squared. Okay, so that's what we're beginning with here. Now it tells us that the point P lies on this curve. Given that the first derivative x, so this is also known as the gradient expression, equals minus 4, so in other words the gradient is minus 4 at point P. Find the equation of the normal at P, writing your answer in that form. Okay, so since we know what the gradient at P is minus 4, therefore the equation of the normal, in other words the normal of that gradient, is the perpendicular gradient, guys, yeah? So if the gradient is minus 4, then the new gradient for the normal is the negative reciprocal, which is plus quarter. Now, just remember, yeah, all you do is flip the sign and make it 1 over, and then you have it. Now, to do this one, since we got most of the equation, we can say therefore, just writing in this form, we have y equals a quarter x plus c. And now, since we know that we're interested in the point, the equation at point P, we just plug in a p coordinate to find c. So we say, all right, at p, which is 4 minus 50, we plug in x for 4 and y for minus 50. We're going to have minus 50 equals a quarter times 4, which is 1, and then plus c. And well, solving for c is quite easy. Subtract 1 and c is therefore minus 51. And that's it, guys. And then we say therefore, for part A, our equation of the normal is just y equals a quarter x. Instead of c, it's minus 51. Yeah, that's one part done. And now finally, find fx. Alright, so this is just completely different, yeah? Looks to me that we have to integrate this equation twice, yeah? So, alright, let's have a go, yeah? So first things first, always write this one in index form, yeah? So I'm going to start from here. So f prime prime x equals, well, okay, so let's break this apart actually. You got root x cubed. Well, if it's a square root, it's a power of a half, so this is just x to the 3 over 2. Bring it back on the top line, it's just going to be 6x to the negative 3 over 2. And then plus x. Now, if we integrate this once to go to the first derivative, so if we're going back upwards, we're going to integrate, yeah? Well, integrate means you're going to add this by 1, so it'll be minus 1 over 2, so it'll be 6x to the power of minus 1 over 2, and divided by itself, which is minus 1 over 2. Same thing here, yeah? Plus, this is just a power of 1, guys, yeah? So integrate this, so it'll be x squared over itself, 2. Now, because we're integrating, you always write plus c. And before we integrate one more time, what I would personally recommend is firstly simplify this equation and find the value c. Trust me, it's going to make it a lot easier. So if you do that, we say, okay, just put this in your calculator. So 6 over minus a half, that's going to give you minus 12x to the negative half. Again, and you can just leave as it is actually. But I'll write plus half x squared plus c. You know what? Keeping this form actually is a lot nicer. So this is your f prime x. Now we have some information to get c, yeah? In the beginning, it tells us that given that f prime x equals minus 4 at p, so in other words, when this part is minus 4, we know at p x is 4. So replace that in. We can say therefore minus 4 equals minus 12 times 4 to the power negative half plus, you know, I actually don't like that form. So it'll be 4 squared over 2 plus c. Oof. So again, you just have to make c the subject here. Go work all this out and then just rearrange it. And when you do that, and I actually need to do it right now. and c here becomes minus 6. Okay, that's not too bad. Now just updating this equation, so I'm just gonna do it over here. So all of this becomes minus 6. Okay. Now once again you're gonna integrate this, guys, and try and get fx. So start from here, yeah. So this is gonna be one of your main results. We can say therefore fx, guys, is just the integral of this part. Now integrating one more time, again you raise the power to plus half, so it'll be minus 12x to the power of plus half over half. And then plus, instead of x squared, it will be x cubed over, what, 2 times 3 is 6. And then plus, oh yeah, this is minus 6. And then you get minus 6x. So if it's just a constant, you stick an x in front, and then you write 1 over plus c. I'm not going to use plus c again, so let's call it plus k. And then therefore, okay, you could simplify this, which is probably better. So you're going to get, well, minus 12 over a half is minus 24x power over half, plus, just copy the rest. X cubed over 6 minus 6x plus k. And that's fx. Okay, now. Alright, so now you want to find that value of k, right? So again, we just have to find any coordinate. And yep, we can still use the same one. We can still use p, which is 4 minus 50, because we actually have, well, values for x and y. And just remember, guys, yeah, when you go back to fx is the same as y. Okay, so we can say at what's the p coordinate? 4 minus 50. When x is 4, y is minus 50. So just plug in all of this into that equation, so replacing all the x values here with 4 and replacing this y value here with minus 50, and then just solving for k. Well, k should actually somehow become 34 over 3. If you're not sure how that works, you know, just drop me a comment, yeah? And then we say, all right, therefore, guys, fx is going to equal, again, copy the whole thing, minus 24x to the half plus x cubed over 6 minus 6x plus 34 over 3. And that's it. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time.